Yeah, hi team, good morning. So today we are going to cover about the streaming replication. So last session we have seen about log-based replication. So streaming replication is one of the most popular and powerful physical replication tool where most of the organizations will use. Okay, so today we are going to cover about the introduction about the streaming replication and how the architecture looks like and what are the main parameters that need to be configured at the master and slave side. And we have a concept called replication slots. So what is a replication slots? And we are going to see how to convert the replication from asynchronous to synchronous replication, because by default streaming replication is asynchronous replication. Okay. And we also see how to monitor the replication and how to do a failover followed by a demo. Okay. So streaming replication, basically what happens, our standby server connects to the master and it will receive the wall files as it generated, basically. Okay. So normally in log-based replication, your master server will push the archives to your standby, right? Whenever your archives generated, so it will push to the standby. Once the wall file 16 MB is full, it has to wait for it and your master will send the archives to the standby. But whereas in streaming replication, it's kind of real-time replication. Whenever the data, the wall records, okay, streamed by the database like master, it will automatically push to the standby server will connect and it will take the wall chunks, okay, as it generated in real time. Okay, it don't need to wait for wall file to be full. Okay, it doesn't need to wait for wall file 16 MB to be full. Its standby server will automatically pull the data wall chunks as usual it generates. Okay, so that is kind of real-time replication, we could say. As log-based replication, we don't need to be wait for checkpoint to be occur or archive timeout condition to be satisfied or 16 MB wall file need to be full. We don't need to wait. As usual, whenever the records capture in wall file, your data will be up to date. Okay. And by default, whenever we configure the stream-based replication, it is asynchronous replication. Okay. It also supports the synchronous replication, but by default, it is async. So here are the architecture, how it looks like. So we have a users and we have master server. Okay, we are going to configure the streaming replication. So for this, we have to set up a standby, okay, which we call it as a master server and slave server. And whenever any changes happens in the wall files in master, okay, there is a background process called wall sender. It will capture those all changes, okay, and it sends to the wall receiver. So at the slave side, we have wall receiver who will receive the changes which has sent from wall sender, okay, and it will apply to the standby, okay, and our master slave configuration is we are going to set up with the read only, which we call it as a hard standby. Okay, this is how the architecture looks like. Okay, here we have a concept called replication slots. So basically, while we configure the streaming replication, we are going to configure with the replication slot. Okay, what is a replication slot and what is the use of that replication slot? We are going to see in coming slides. And now we need to see what are the parameters that we need to configure, what are the main important parameters we need to configure for streaming replication. Okay, the main important thing is wall level. Okay, so we know that wall level, which determines like how much information it has to return to the wall file. Okay, and it is a replica, right? So for any kind of replications, okay, we have to give the default value replica, because for replication setups, if you have a master and standby setups, okay, it should be replica so that it has enough information to write in the wall files. Okay. So, but whereas if you give minimal, that is only feasible for standalone missions. Okay, since it is a physical replication, we should give the replica for wall level. And we have wall lock hints. Okay, what is the wall lock hints? Basically, whenever your standby goes out of sync, okay. So again, maybe after 1 hour, your standby come up. So again, you want to join that particular node with the help of PG rewind capability. So we use this wall lock hints. Okay, this we will understand more. For example, you have did a failover. Okay, since your primary is not since your primary is not available. Okay, and you did a failover. Now your standby becomes a primary. After few hours, your primary is back. Your old primary is back. Okay. At that moment, if you want to join that particular node into your replication, so we have something called PG rewind option. Okay, with the help of PG rewind, we can able to bring back our old cluster and we can join into the replication. So that is the reason we are going to configure this wall log hints parameter to be on. By default, it is off. Okay, we should on this so that we have the PG rewind capabilities to join the node back to the replication. And here we have max wall senders. Okay, basically this is, we know that we have a background process, a wall sender and wall receiver, right? So for this, we have to configure max wall sender, which is the default value is 10. Okay. So this value specify how many connections that has to be connected from primary server. Okay. To stream your data, it has to connect to your master, right? So it has to stream all the data, whatever it is generated as it's generated from the master. So this is the value which we have to specify. By default, we should leave as a 10. Okay. So 0 means the replication is disabled basically. So your replication will not work if you have set to 0. Okay. So we should set the default value 10. Okay. And we have wall keep segments. So basically this wall keep segment is old parameter. Probably before 9.4, they used to set this parameter. So what this parameter specify? So whenever you have a lag between master and slave, okay. So your archive should not delete basically. So we can specify like how many, if your standby is behind the value which you have specified in the max keep segments, okay. So it will remove your wall files, right? So this will take care of, you know, in order to protect your wall files, not to delete whenever your standby is so much lag. Okay. So in previous versions, they used to set like this parameter before 9.4. Okay. So, but later 9.4, we have something called replication slots. So replication slots will be managed. If your standby is out of sync, it will keep on track how much wall files it has a lag. Okay. It won't delete the archives or wall files, okay, from the master. So this is something old parameter they used to configure, but now this parameter is no longer used. Okay, I think it is deprecated. Okay. Now we have a parameter called hot underscore standby, which we have to keep in on, especially in standby. Even if you keep in master, no problem. Okay, this parameter will make sure it will allow only read-only connections. Okay, when it is in the standby role. So if it is a primary, it will ignore. Okay. So this will make sure it will allows only read-only connections if your role is standby. So these are the main important parameters. First is wall level, which will make sure it will write the enough information to the wall files or wall lock-ins. Whenever your node is you want to join back to the replication, the fail node, you can use PG rewind capability and you can use this wall lock-ins parameter. And we have max wall senders, which will make sure that the number of connections that has to be connected from standby server. Okay, we have to leave as a default 10. And wall keep segments, this parameter we used to define in older versions to protect the wall files if your standby is behind, more behind on from your master. Okay, and later versions they are using the replication slots. And we have hard standby, which will make sure our standby will be in read-only mode. Okay. So we have one more parameter called max underscore replication slots. Okay. That is for replication slot. So that we see now what is a replication slots and how we have to configure this replication slots. So basically, whenever your standby is out of sync, where in wall-based replication, your primary doesn't, it not keep any track if your standby server is out of sync, right? So it may be chance that your wall files may be purged, or even the master is not aware that your standby is out of sync, right? But whereas in streaming replication, we are going to configure with replication slots. When you configure the replication slots, even though if your standby goes out of sync or it is not online, okay, even though if it is offline, replication slot is aware of how much lag it has, and it keep track of how much lag and how much wall files that it needs. Okay, whenever your standby is back, how many wall files it has to apply. So those all information, this replication slots will keep track. Okay. And as discussed, it came with 9.4. So before they used to protect with the help of wall keep segments, okay, by this parameter. Okay, now the replication slots can be created with the help of PG base backup while we configure the backups, or we can also configure manually with the commands. Okay, with the create replication slot utilities, we can able to create the replication slots. And we have to enable one parameter called max replication slots, which is the default value is 10. Okay, this we are going to see in lab how we can configure this replication slots as a part of our PG based backup. Okay, so basically replication slots are two types. One is physical replication and logical replication. So basically we are using currently we are talking about physical replication. So we are going to configure about physical replication slots. So logical replication will be used for the logical replications. So this is the syntax how we can create the replication slots manually. Even you can configure with the help of PG based backup as well. Okay, that we are going to see. So this is the function PG create physical replication slot and the replication slot name. This can be any name. Okay, and this is the replication slots we can monitor. Okay, select star from PG replication slots. With this utility, we can see how many replication slots we have, and this replication slots will keep track of all the information about your standby, how much lag it has, lagging information, everything we can see with the help of this PG replication slots. And with the help of PG drop replication slots, we can drop the replication slots. And this is the utility for logical. So this we are going to discuss in the logical replications. Okay. So this is the functions which will be used to create manually, but as a part of PG based backup also we can configure the replication slots automatically. Okay. And now once we configure the streaming replication, and it's very important for a deviate to monitor the replication, right? So there may be sorry, anyone have any questions? Yeah. So most reasons, if you see, okay, the replication issues is because of the network failure, or if you have any heavy load on the primary, it will restart, or if any load on the standby. So there may be a chances of replication failure, and maybe any other failures like hardware or anything, right? So basically, we should have a good monitoring utilities or views, we could say, right? So for this, for streaming replication, like in Postgres, we have a utility called PG stat replication view, which is very useful monitoring view, okay, where we can check all the details, okay, how much, what is the last LSN it has applied, okay, and what is the last LSN it has sent, and what is the last LSN it has written and applied. So those things and all we can see with the help of PG stat replication view. and this is a very useful view. Okay, with the help of this view, we will monitor the replication between master and slave. Okay, apart from this, we also have few more functions. Okay, this function is like whether your standby is in standby mode or not. Okay, this we have seen in the log-based replication as well. And we also have few more functions like pg stat wall receiver. So what is the last wall receiver, and which LSN number it has received, and which LSN it has written, okay, to the standby. So these all functions we have to monitor the lag manually. Apart from this, we also have this pg stat replication view. Okay. So this we are going to see in our lab, how to check this all things. Now we have synchronous replication. Basically, by default, your streaming replication is asynchronous replication. Okay, in order to convert this replication into asynchronous, we have a parameter called synchronous standby names. Okay, so synchronous standby names, we have to give star, okay, which means it will apply to all standbys. If you have 2 or 4 standbys, this is applicable for all standbys. Okay, all your replications will convert into your synchronous replication. So we know synchronous replication, right? Whenever you do any changes, okay, first it will apply in the standby, and once you get the acknowledgement from standby only, it will apply in the master, right? Because of some reasons, if your slave server or standby server is not available, it will not allow the transactions even in the primary. It will get hanged. Okay, so if you are going with synchronous replication, which is zero protection, zero data loss, okay, but you should have multiple standbys in this case, because it's one standby is not available. So you have other standby so that you can continue your operations in master. Otherwise, even you cannot perform your operations in the master side as well. Okay, this is how we can configure the synchronous replication. This also we see in lab. Okay, how we can do this. Only this parameter we have to add. That's it. Now failover. So we know that in Postgres, okay, by default you will not get a opportunity to do a switchover. So we have only failover concept. So if you're due to some reasons, if your master is not available, okay, because of some hardware issue or anything, and your SL is going to breach, okay, you are going to do a failover. DBA has to do a failover, and Postgres doesn't support any automatic failovers solution as well. Okay, as a DBA, we have to do this failover manually. So again, we have similarly 3 methods to do a failover. One is pgctl promote or pg promote function or promote trigger file. This is the trigger. Okay, with the help of 3 methods, we can do a failover operation. So in log-based replication also, we have seen like how we can do a failover. Okay, so this is a failover. This also we see in the lab. Okay, so this is about the streaming replication. Do you have any questions? So that we can jump into the lab.
Do we have any PG rewind kind of thing here?
Yeah, we have PG rewind. Actually, we have seen here, right? So PG rewind is one of the utility where you have a capability to rejoin your node back. Okay, in case of this also we are going to see in the rep manager. Okay, so next we are going to discuss about the rep manager, right? So in the rep manager, once you do a failover or switchover or maybe failover, okay, your old primary is not able, your primary is crashed, okay, you are going to do a failover and your standby will become a new primary, right? So your old primary comes up after few times, okay, maybe few hours, okay, you want to rejoin it back to the replication without a full backup, okay, you are going to do, you are going to keep track with only incremental changes. So that time PG rewind is helpful, okay. PG rewind is like incremental backup, okay. If your standby is out of sync, usually in Oracle we do incremental backup, right? So similarly, with the help of PG rewind, so up to which LSN it has applied in that particular node, okay, in that standby, it will take the backup from that particular LSN and it will apply those changes. Okay, that is a PG rewind. This also we are going to see practically. Yeah, so let's go to the practical part. Okay, and one more thing is, okay, this we will discuss. Okay, once we do the lab setup in streaming replication, we may also have something called conflicts. Okay, so what is the conflict basically? So as we know, so first of all, in physical replication, whenever you do a vacuuming operation in primary, the same command it will execute in the standby or not. Okay, these questions you may have, and for example, in primary, okay, so I have in table 100 records. Okay, in standby server we are going to allow read-only operations, right? So in standby you have executed a query to fetch 50 records from the standby. The same 50 records, whatever you have filed in the select statement from the standby, we have run the delete statement in the primary, for example. Okay, and auto vacuum process will automatically delete those date tuples, right? That 50 records in the primary. It also tries to delete same in the standby, right? So, but in standby, you are trying to fetch that particular records. Okay, that is very long running query. It is still running. So, but you have done the delete operation in the primary. So at this moment, you may have something called replication conflicts. Okay, because of this MVCC architecture, you may have some problems that we are going to discuss more. Okay, don't worry about that. First, let's discuss about replications. Yeah, someone has any questions?
Sorry, my mistake. My mic was on. Okay.
Yeah, actually, we have two missions. So as discussed actually in the last session, for log-based replication, we can just clone a mission instead of building the new mission. Okay, you can just try to clone the existing mission. It will create the new server. Okay, the only thing is it will have the same host name, but IP will be different. So we should not confuse. So that is the reason I have kept, this is my primary in the green color. Okay, and this is my standby. So standby IP is 1.4. Okay, whereas my primary IP is 1.11. Okay, so we will see how to set up the streaming replication now. Okay, so my two Postgres clusters is running in primary and standby. Okay. The first most important thing is we have to enable the necessary parameters, right? So here we don't need any SSH connectivity because we are going to create a separate user for replication, and we are using that user to connect because your standby has to connect and fetch the details, right? From the primary wall files, as whenever it generates any records, any wall changes will capture. For this, what we are going to do, we are going to create a separate replication user, and with the help of that user only, the standby will able to connect and it will fetch. Okay, so that for this we don't need any SSH connectivity for now. So let's go to our master server, PG data, and open the postgresql.conf. So we need, I think this is the new cluster. Okay, let me enable the necessary parameters like listener address, because if you want to accept any remote connections, we need this to be allowed. And let me enable the port. Okay, and we have to make sure our cluster is in arclog port. Okay, so this is the normal parameters which we need to configure, right? And archive command. Maybe I will configure /home postgres.org. This is my path. Okay, we have to make sure this path has to be created. Now, the main important parameter is wall level. Okay, wall level should be enabled as replica. Okay, and when you come here, there is a parameter called wall level hints. Okay, so we have to enable this and keep it on. So still what parameters we have? So we have hot standby. So this is not required in master side, but anyway, even though if you keep it, it won't care. Okay, so we have, but this has to be configured at the standby, definitely. Okay, and we have something called primary connection. Okay, so this primary connection will be taken care by replication slot. When you create a replication slot as a part of our PG based backup, so that this parameter will be taken care by that replication slot. So for this reason, we don't need this primary connection parameter for now. So why this parameter we need is in order to send your data, right, from master to primary, we need this parameter, but this parameter will be automatically taken care by our replication slot. We'll see that. Apart from this, we have max wall senders, right? Yeah, here. So we have max wall senders. By default, it is 10 and max replication slot is 10. So this is the maximum number of connections that has to be read from wall, your background process, wall sender process, right? This is the number of sessions, okay, for the wall senders and wall receivers. And we have replication slot enabled. So if you enable replication slot, it will keep track of your standby, right? So these are the main parameters, I think, which we need. So we can just verify one more time. We have enabled wall level, okay, and we have enabled wall lock-ins, and we have enabled maximum max wall senders, and we have enabled replication slots. Okay, so this these are the mandatory parameters that we need. Before we start the cluster, we have to make sure we have to create this folder, right? Home plus org. Okay, let me do with root user because I don't have permissions. Yeah, I've changed the ownership and everything to /home itself so that I have permissions next time whenever I want to create any folders. Okay, so now we have our archives, archive folder as well. Okay, so our archives will generate here. Okay, so now we have enabled the necessary parameters. And now one more important thing is we have to create a separate user for replication. Maybe I will just do create user. So maybe the name is rep user for replication. So this user should definitely have the replication privilege. Okay, this is very important. So I'm going to give the replication privilege. So replication is one of the privilege, one of the system level privilege, right? So this privilege we have to give to this user because this user will act as a replication user. Okay, this user we need to allow in the hpa.conf as well. So with the help of this user only, our standby will connect to the primary and it will fetch all the data, okay, from the wall files. Okay, maybe I will give the password with password. I don't need this /tu plus. So if you see, I have created the user called rep user and it needs only replication privilege. Okay, replication privilege is one of the system level privileges which we need to configure. Okay, so I have created a user and now this user I have to allow in the hpa.conf file. Okay, so let's go to PG data. We have PG underscore hpa.conf. Okay, so in hpa.conf, we need to allow this user in the replication user. And we also need to allow the IPs in IPv4, right? So like both primary IP and standby IP, it has to connect, right? So we need to allow those IPs. So for this, what I will do, I will just allow all the databases for all the users. IP is 198 dot. So let's take the series of both primary and standby. So 192 dot 168 dot 1 dot. Okay, probably instead of adding two IPs, 1.4 and 1.11. 1.11 is our master IP and 4 is our slave IP, right? So instead of allowing two separate IPs, I will just go with .0/24, which is CADR format. Okay. So within the subnet, whatever IPs it has, it will allow all the IPs with this range. Okay. In this class. So I'm going to configure as MD5, which will allow the users to ask the password. Okay, I don't want to be trusted. Now I also need to add the specific user in the replication. Okay, our replication user is rep user, which we have created just now. So I'm going to allow this IPs, and this is my method algorithm. Okay. So these are the things which we need to add in, hp.conf. Here we are going to allow for. So here we are going to allow for all users. Okay, and in the replication side, we have to add this rep user, because from this rep user only our standby will connect. Okay. Since we have done so many changes in our configuration file and hp.conf, we need our cluster to be restored, right? To affect all the things. So I'm going to restart my cluster. Okay. So just verify our parameters like rk_command wall_level wall log hints and max wall senders. Okay, so all the parameters has been enabled, and we can try to do a manual log switch whether archives is generating. You can just verify in our archives is generating. Okay, so far what we did, we have enabled necessary parameters and we have created a replication user, okay, with replication privilege, because this user we are going to use for the replication, right? Your standby will connect with the help of this user and it will capture all the details from the master, whatever it generated in the wall files. And we allowed this user, okay, in hpa.conf, right? Because whenever your standby try to connect to your primary, it has to accept the connection. Okay, otherwise it will not allow the connections. Okay, and now so if you want to verify the hpa.conf without going in the OS level, from here we have a view called pg_hpa file rules. Okay, here it will show whatever the IPs which we already added in the hpa.conf. Okay, so here we have added the replication rep user and we allow this range. Okay, if you see the subnet mask, so 25.25.22.25.0. Okay, this all IPs we have allowed. So within this range, our primary and master both will be fall in the same network, right? So we don't need to worry. Otherwise, if you don't want in the CADR format, you can add it in a separate, maybe 1.4 for your slave and 1.11 is for your primary. So like this we can allow. Otherwise, we can allow the same the CADR format, this range, okay, by specifying the net mask. Now, now we have to take the backup. Okay, so let's come to the standby server. So in my standby, already a cluster is running. So let me stop this cluster and I will take the fresh backup with the help of PG base backup. So let me go to PG data and I don't want anything. Okay, I'm just removing RF minus RF star. because I'm going to take my fresh backup in the PG data location. Okay, instead of taking the backup from the primary and copying or transferring all the backup pieces to standby, what I will do, I will directly connect from here to primary and I can take the backup, PG based backup, because I already added a user rep user, right? With the help of this rep user, I can connect from the remote machine, which is a standby, and I can take the backup in the standby server itself. Okay, how we can take, we will see. So first of all, we can just PG based backup -- help. So we can see what options we have. Okay, so we already know how to take the PG based backup. This is the directory where your backup will be stored. Here we use the PG data backup, right? Sorry, PG data location to take the backup in the standby mission. And we'll take with the help of -x option so that it will fetch all our WAL files as well parallelly. And yeah, this is important. Okay, -r option. So what is the -r option basically? So whenever you use -r option, it will treat that you are going to take this backup for the replication. Okay. So whenever you take with the -r option, it will treat like you are going to take this backup for replication for building the standby, so that it will add the necessary parameters, okay, to your pghpa.auto.conf. Which parameter it will add basically? There is a parameter called primary connection, which I have shown you in the our parameter file, right? Which is primary_connection. So that parameter it will add here. Either you have to add that parameter manually in the your PostgreSQL.conf, or you have to use -r. Okay, so that this will write all the configuration for the replication, whatever it is. So whatever it is going to use, okay, that we'll see practically so that you will understand. And one more important thing is something called replication slot. So whenever you are taking the PG based backup, we also take along with the replication slot, so that your replication slot is aware of your whenever your standby is out of sync. Okay, so with the help of replication slot, you can able to keep track of your standby. So this, with the help of replication slot, we are going to take the PG based backup. Okay, and see, this is the option to create the replication slot, and this is the option to use the replication slot. So we use these options to take the PG based backup. Okay, let's take the PG based backup. And the first thing is we have to connect to our primary, right? So I'm given PG based backup -h. Here we have to give the IP of my primary. So I'm connecting to remote primary mission, and I'm going to take the full backup with the help of PG based backup. And from which user I'm going to connect? From rep user. So this is the user which we already created, and we already added this user in the hpa.conf so that it will allow the connections from remote mission from primary. So -u, the ref user, and data directory we have to specify, right? So here I will use my PG data directory. You can use either variable or you can give the full path. Okay, since we already have variable PG data, it will store in the standby PG data location. Okay, your backup pieces. And we are going to take with a plain format. Okay, so that I have used the format plain. And we are going to take with stream method, okay, which is -x, so that it will also capture all your WAL files. Okay, and I want to see my progress, and I want to see the log. Okay, that is verbose. So up to here we already aware of in the PG based backup. Now we'll use the replication slots. Okay, so what is the command to use the replication slot? So first thing is we have seen -r, right? This will treat like this backup is for standby. Okay, so I will use -r. And how to create the replication slot? So we have something called -c, right? So with the help of -c, I'm going to create a replication slot. And we have replication slot name. Okay, so here I will just give -s. maybe I can just give any name. Okay, so what I will try to give, I will just try to give for standby or maybe any name. Maybe I will give PG for standby. This is my replication slot name. You can give any name. Okay, so don't worry about this name. What else we have? Yeah, that's it. So this is enough. So PG based backup, we are connecting to primary with the help of rep user, and we are capturing the backup from master, and we are storing in the PG data location of my standby. And I'm taking with the plain format, and this is the stream method to check the progress of my backup. This is verbose to show the output of my backup, what is happening. And this is this R is like we are going to take this backup for building the standby. Okay, so that this will make sure it will write all the configuration files in the hpa.conf, especially primary connection. If you are not using this -r option, that primary connection parameter we have to add manually in the our PostgreSQL.conf, and this is to create the replication slot, and this is the replication slot name. Okay, so let's try this backup. What it is telling, unable to connect to server, no route to host. Okay, which means something it is blocking in the same server. I think we have to disable firewall. Okay, so let's stop the firewall and disable it at the both sides, even on the master side. Okay. Now connect to Postgres users and try to take the backup again. Okay, it is asking password for rep user. So we can just give the password for rep user and your backup is initiated, and it is telling the progress. Okay, and if you see, the replication slot has been created. And you could also see the background process will be start automatically. Okay, which is PG receiver at the standby side. Okay, we have wall receiver. Okay, at the primary side we have wall sender background processes. Okay, here wall receiver background process has been started, and the backup has been completed, and it has also given the backup mainfest file. Okay, now if you see ls minus ltr, currently I'm in this location, just go to PG data. Now you have all the files which is copied from the primary. It connects directly to the primary and it will fetch all the files in the standby. It has generated the backup label file. And if you observe, there is one more thing called standby.signal. Even we haven't created the standby.signal. Automatically PG based backup creates the standby.signal. Okay, who will create the standby.signal? -r will create. So we have used -r, right? So -r will write all the necessary configuration files for building the standby. Okay, it also create automatically the standby.signal file, even we haven't created it. And if you observe one more thing, you just do cat of your PostgreSQL.auto.conf. It has added automatically a parameter called primary connection. Okay, so what is the use of this connection? So it connects to your host is 1.11, which is your primary. Okay, it connects to this primary with the help of rep user. Okay, and with the help of this password. So it's going to connect and it will fetch all your wall files. Okay, whatever the changes happen at the primary, it will pull those details with the help of this parameter. Whenever you are taking the PG based backup, if you're not using -r option, okay, this you have to add manually, primary underscore connection in your standby configuration file, PostgreSQL.conf. So you don't need to do all these things manually if you use -r. Okay, so -r is one of the beautiful option as a part of your PG based backup. And it also added your replication slot name, whatever the name which we have given. So now we don't need to do anything directly. We have to start our cluster. That's it. pgctl start -d $pg data. So we are going to start our standby cluster. So whenever you start your standby cluster, it will automatically go to the standby mode because your standby.signal is created, right? Automatically it will go to the standby mode. So even we can go and verify in the log file. So cluster has been started. If you verify your alert log, okay, so what it does, it does the recovery, and whenever recovery is done, it is went to standby mode, which means read-only connections is accepting. Okay, and if you see, started streaming from primary. Okay, your standby now is in the streaming. Okay, it will automatically capture the details from the primary. It will connect automatically and it will capture the changes and it will replicate. So now we are going to see PG is in recovery, which means this is to make sure that your cluster is in standby mode. Okay, it is in standby mode. If you see in the master, it is false, right? Because this is master. So your standby server is in recovery mode, basically. So now we have set up the replication. Now we are going to test the replication is working properly or not. Okay. So let me go here. Create database test. Just come here and do -L. Your test is immediately replicated, right? See, just I press enter and came here and just do -L. Your test database has been created in the standby as well. Okay, so if you connect to test database. Okay, so let me connect to test database here. Currently, I don't have any tables. Okay, so let me create a table. The table has been created in the standby as well. Okay, let me try to insert. The record is inserted. So all the records has been replicating very fast. This is a real-time replication. Okay, so you don't need to wait for wall file to be filled or checkpoint to be occur as a log-based replication. Stream-based replication is very real-time replication. It's very, very fast. Okay, so it will stream very fast with the help of wall senders and wall receiver. Your data will be quickly captured. Okay, your standby is going to capture all the changes, whatever it is done at the wall file. This is called real-time replication. Okay. Now we have seen how to set up a replication, and we have also checked the replication is working. Whenever we do any changes in our primary, it is automatically capturing in the standby. So even we have verified the standby is in sync. Okay. Now we are going to see few of the views. Okay. For example, replication slots. So we can just go and do select star from PG underscore replication slots. So we have created with the help of replication slots, right? So this is a replication slot. Okay, this is the replication slot which we have created, and this is a physical replication slot. Okay, and it also captures the details like wall status and LSN details. Okay, this is a replication slot name. So this replication will keep on track of your standby if it is out of sync. This replication slot will take care of not purging any wall files, and it will keep track of your standby details. Now, apart from this, we also have command called, if you want to check the lag, okay, pg stat replication. Okay, if you see pg stat replication, application name is wall receiver. Okay, your wall receiver is connecting to your primary. Okay, with the help of rep user. Okay, and this is the PID and this is the OID of this user, rep user. And if you see the client is your standby client. Currently I'm in primary, right? So when I check the PG stat replication, it is giving the standby application name and standby IP address. Okay, and the client port and streaming. Okay, it is a stream-based replication. And if these three values are same, okay, your replication is in sync, right? So send LSN, write LSN is very important. Okay. And you see the replication mode is asynchronous replication mode by default. Okay. So this is how your replication lag can be checked. Okay. So basically if you found any lag here, you could see some values. This many seconds you have lag or something. Okay, for example, let's try to insert few data, maybe few records, so that we will understand. Yeah, just give me a minute. I'll try to capture that function. So what I'm going to do is I'm going to create a table, okay, and I will try to insert some huge amount of data into that table so that we will understand how it will show the lag. Okay, for example, in the test database, I'm going to create this table. And I'm going to create few functions to insert the data. Okay, random function, and along with this, I'm also going to create one more function called insert records. Okay, so that with the help of these functions, we can able to insert the records. Now I'm going to insert the records. Okay, if you see, okay, let me share it again screen because you may not able to see the other screen. Now let me take the other duplication session. So let's start from PG underscore start underscore replication. If you see now, we could able to see some lag because parallelly in other session, some insert statement is going on, right? Like the huge bulk of inserts, okay? So currently this much lag we have, it will show here. This much lag, okay, in milliseconds or seconds or minutes and hours, okay? This much lag only we could expect. So if you see, even though if you do like huge inserts, we could able to see very less milliseconds of gap. Okay, you don't have much even in seconds. In milliseconds only you have the gap. Okay, once the insert statement is done, probably we may understand. So even you see here, the table name is employee. So for now still 0 rows, one still your insert statement is going on in the primary. So let's wait.
So in order to check whether the replication is in synchronous mode or asynchronous mode, so you show the one view, right? Page start replication. Apart from that, any other method we have to check the synchronous mode?
No, only this is the view which we have. We can check from this view only, whether it is asynchronous or synchronous mode. Yeah.
One question, is there a way to pause the replication for some time?
Yeah.
Like in data guard, you have apply off and all that, right?
Yes. You have to set the max underscore replicate. So we have parameter, right? So max wall senders. So you can just make it 0 so that your replication will be passed. No, because
Oh, okay.
your wall senders and wall receivers are no longer, there is no sessions that can be connected. So if you keep max wall senders 0, your replication will be disabled or paused for some time, like how much time you want, you can just pause it.
Okay, thank you.
So it's same like a block to block copy, like Oracle, or it differs?
Same block to block copy.
Okay.
Yeah, so it is same block to block copy only. Okay, so now we can go and see in the standby. My insert is done. Okay, your standby is already in sync. Okay, this meant because we inserted in our primary. Okay, so this may take some fraction of seconds to have the lag 0. Okay, now the lag is 0. Okay, there is no lag. If this is how we can monitor the replication lag with help of PG stat replication. It is very, very fast and real-time replication. Okay. Now we also have few more functions. Okay, that let's go and see that few more functions, like what is the how much lag we have seen in the PG stats replication, right? So we also have few more functions. Okay, maybe in the primary side we can see what is the current wall LSM. So currently this is my wall LSM. So we can also check at the standby side what is the last wall LSM received. PG last wall received. Just a moment. Exactly what is the function? Okay, wall receive LSM. Okay, like this we can compare what is the current in the primary and what it has written in the standby. So with this we can also check whether it is sync or not, like how we check it RK log list in Oracle to compare what is the last RQ generated and something like this. We can compare with the LSN, okay, for the replication gap, okay, to be checked. Now we can see how we can enable our cluster in synchronous mode. So for now, we have our default replication mode is async, right? So we can just go and enable it back to the synchronous mode. Sorry, we can convert this replication from async to sync. Okay, so currently this is sync. As discussed, we have a parameter called synchronous. Okay, this is the parameter. Okay, this parameter we can enable so that it will convert from async to synchronous mode. So we can see how we can do that. Okay, so I'm just going to do alter system set. Okay, so this is this parameter is like static parameter. We definitely need a bounce back. Let's see. Okay, it needs a bounce. Okay, let me restart my cluster. Let's connect to pSQL and just verify that parameter has been added now. Okay, if you just check the select start from PG stat replication. So it has converted the state to sync now. Okay, so now it is synchronous replication. Now let's do a test. Okay, now for example, what I'm trying to do, we have a database called test. And So I'm going to try to insert a record 104. Okay, it will replicate as we know. Now, because of some reasons, my standby is not available. So what is the mode of synchronous mode? Whenever you do any transactions, okay, first it will go and apply in the standby, and then once it receives the acknowledgement, then it will apply in the primary. So now my standby is no longer available. Now you can see in what situation where your transactions will get hung in the primary as well, because your standby is no longer available. So this is some of the dangerous situation you will be. So that is the reason whenever you are configuring the synchronous replication mode, okay, it's good to have at least two standbys. If one standby is not available, you have the other standby. So either it will not allow the transaction in the standby and primary both. Okay, this is like zero protection loss, right? So even it will not allow the transactions in primary as well. It will be, all the transactions will be freeze, okay, or hung until your standby comes back. Okay, so that is the reason. So whenever you do the synchronous replication mode, it's good to have at least two standbys. Okay, so because your transactions will get hung. So let's start the standby server. Your transaction is completed, right? So this is how you can convert the replication mode from async to sync. Okay. Now because I did with alter system set command, right? So this will be added in the PostgreSQL.autoconf. This parameter. So if you don't want to be converted into synchronous mode, you want to roll back. Okay, you can simply do alter system reset all. So reset all means it will convert all the parameters. It will roll back. Okay. Since I have only one parameter, I'm going with the reset all. If you want to convert everything, you can also do reset all. But if you want a single thing, you have to just mention that parameter. Okay, to reset. Now, this parameter has been purged now. Okay. In order to effect, probably we need to restart. Let's see whether it is converted to sync or asynchronous mode. Okay, let's restart the cluster because it has to affect. So next we do the failover situation. Okay. Okay, it came back to async mode. Now let's do a situation like failover situation. Okay. Okay, before this failover, probably we also need to do some more testings regarding vacuuming. So probably what we can do, we can leave this as it is. Okay, probably tomorrow we will continue from here. Few of the points that need to be considered as a part of streaming replication, like vacuuming, and whenever you do any long running transactions in the standby, okay, you may have replication conflict. Okay, so those two things we can discuss tomorrow. Okay, followed by rep manager theoretical part. Okay, and followed by failover situation in the streaming replication, how we can do failover. Okay, so that's it I have for today. Probably tomorrow we'll discuss more things in the same replication, streaming replication. Any other questions for today class? How to configure the streaming replication and things? Okay.
PG event is a kind of new utility, or like we need to.
It is a utility. If you see PG rewind, that we are going to see. Okay, you have PG rewind option as well. PG rewind is as a part of your binary set will get. Okay, this utility, you if you want to use this utility, you have to enable wall log hints parameter so that it is aware of how much LSN it has lag and everything. So this PG rewind, we are going to see in the rep manager, how we can bring back our cluster. Okay. See, resynchronizing a cluster with another copy of cluster. Okay. So if you want to sync the cluster from the other cluster, you can use this PG rewind option. So this we will see, don't worry about this PG rewind. Yeah. Any other questions? Yeah, if any no other question, probably we can close for today. Probably we can catch tomorrow, and tomorrow we'll discuss regarding a few more scenarios, okay, regarding vacuuming and conflicts in stream-based replication. Yeah, so that's it we have for today. Probably we can catch tomorrow. Thank you. Bye.